Hello and welcome to 5-Minute Math. Today we are looking at the Algebra 1 concept of domain and range. This is standard A.2A in the great state of Texas, and we are using item number 18 of the 2022 released STAAR test. If you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So we have a florist making bouquets of flowers. Each bouquet has 9 flowers, and the florist will use no more than 8. So no more than 8 bouquets. Each has 9, and we've got a linear relationship here between our number of flowers and the number of bouquets. So we are looking for the domain of the function. All right, so we need to define domain and its counterpart range, because we're going to need to be able to distinguish between the two. And unfortunately, these definitions are not on your reference material, so you have to know this before you come into the test. So the domain is the set of all independent variable values. Now, for shorthand, a lot of us just kind of think of them as the x values. It's not always the x. In this case, the independent variable is represented by an x. We see the graph here, right? But it's the number of flowers used is y, and the number of bouquets is x, right? It easily could have been b. Sometimes they'll replace it with a letter from the story problem. So it's not always the x. It could be the b if it wanted to be. But the domain is the set of all independent variable values. So you start with those independent variable values, you do something with it, you multiply, you add, subtract, then you get the range, right? So that is the set of all dependent variable values. So these variables depend on what you do to the independent variable values. And for the most part, they're going to be the y values, which they are in this problem. But the number of flowers used is y, so it easily could have been f. So we're looking, basically, since we're looking for the domain, we're looking for our x values. Now we need to notice our data here looks a little bit different. Even though it's on a graph, it's what we call discrete data. So all of our answer selections you see have these brackets, and they're just counting numbers. Discrete data is made up of whole concrete numbers that you can find by counting. So 1, 2, 3, 4, 5, so on and so forth. Doesn't always have to have an interval of 1, right? You see J has got intervals of 9. That's different than what we would see, so those are represented by just the dots. So that's different than what we normally would see, which would be the continuous data. That's just the straight line on a graph. So that's all possible numbers between points. So it could be whole numbers, it could be decimals, could be fractions, even could be, irrational numbers. So we're looking for discrete data, and we are looking for the domain. So let's see what we have here. We've got, you notice it's counting by 2s across the x-axis. It's counting by 18 simply because every bouquet, right, has 9 flowers. So you need your y-axis to have a much bigger interval there. Well, let's just, once we know that we're looking for the x-axis, it's not that difficult, right? Let's take a look at our points. And I'm just going to look at the x-coordinates of our points. I don't need to plot the xy because I'm just looking for the domain. So that's 0. That's your 2 right there. So we're going to call that 1. And that's 2. That's 3. That's 4. That's 5. That's 6. 7. 8. That's it. That is your domain. This is the set of all numbers that are possible in this function because they put the limit of no more than 8, right? And you can, for the most part, in most problem situations, you can usually start with 0. So it's between 0 and 8, right? So f is decent, but it's missing the odd numbers. It's just picking up what's on the graph, right? G, that is our answer. And then H and J, those pick up the range. And we don't need the range, we're looking for the domain. So the answer is G.